Hello, my name is Mr. Wilke. We're learning statistics. We just started talking about hypothesis testing or significance testing. So let's talk some more about that. We're not going to quite formalize it today because it's a short day, but we're going to formalize it probably next time. But as you know, it's going to be four-step inference, so let's talk about step 2, which would be the conditions. So the conditions for a one-prop z-test or a z-test for proportions. One sample z-test for proportions. Random. It's got to be random. If it's not random, it doesn't matter. Okay? So we need to pull our sample from a random sample. Okay? Or we need to pull a random sample from our population. That makes more sense. Okay? Has to be random, otherwise, well, there will be bias and it doesn't necessarily give us any sort of significance. Okay? So, random, we've got the 10% rule, which states what? Does anybody know? Good. Population size has to be greater than 10 times the sample size. Okay, so population has to be greater than 10 times the sample size. We know this, it makes sense. We've talked about that before, plenty. Large counts, so in P has to be greater than or equal to 10, in Q has to be greater than or equal to 10. Now, we don't know P, so what we use, instead of using P hat this time, we use P naught. Okay? P naught should be close, right? Because they're claiming that it's true, so it should be close enough that if in P naught and in Q naught, or in 1 minus P naught, that makes more sense. Okay, sorry. Greater than or equal to 10. Okay? If these conditions are met, we can proceed with a one sample z-test for proportions, or just abbreviated a one prop z-test. Okay, now let's talk about what step 3 is going to look like. Step 3 is doing the inference procedure. We're going to find what's called the standardized test statistic. So the standardized test statistic is going to be the statistic minus the parameter over standard deviation of statistic. Now, let's talk about what these things mean for a one prop z-test. So the statistic is P hat. The parameter is P, but we don't know P, but we're using P naught over the standard deviation of statistic, which is what, root PQ over N, but we don't know P, so we use P naught. And that's it. Now, the standardized test statistic, this is just a z-score. Why are we able to use z-scores? Well, because when in P and in Q are greater than or equal to 10, it's approximately normal, okay? So since it's approximately normal, we can use a z-score. So, going back to our example from last time, which I remember really well because clearly it's the same day, I'm wearing the same shirt. right? Okay, so going back to our example from last time, we said H naught was P equals 0.5, HA was P was less than 0.5, right? We had P hat was, what did we say, 207 out of 500, or that's what? 207, that's what, 41.4%? Okay, so let's find the z-score here, and we'll talk about how to calculate the p-value. So my z-score is going to be 0.414 minus 0.5 over, do we use 0.414 or 0.5? We use 0.5. Over 500. Now, I'm going to work this out on the calculator over here to see what we get. Actually, I'm going to bring up the calculator on the screen, and that way I can show calculator commands. So we wanted to take I'll do it over here. So we have 0.414 minus 0.5, and we're going to divide that by the square root of 0.5 times 0.5, which is 0.25 over 500. And we get a z-score of negative 3.846. Now we want the probability that z is lower than that. So we can do that using the normal CDF. Can we use the z-chart? No, we can't. Why not? Well, because the z-chart doesn't go this far. So what does that mean? It means the probability is ridiculously small. If I wanted to do a normal CDF, I could do distribution menu, normal CDF, go from negative infinity. Usually I use -8, but since I want to get as much as I can, since this is so small, it's still, what, 0.00006? That's almost no chance of that happening just due to chance, which means we would reject H naught, that P was 0.5, in favor of HA, that P is less than 0.5. Okay, so this tells us that there's very, very little chance of getting a sample size of 41.4%, or sample proportion of 41.4% with a sample size of 500 if the true mean was actually 0.5. Okay, do we understand how p-value works? Good. We can also go stat, go over to tests. One prop z test is 5. So p naught was 0.5. We said to do 207 out of 500. We said we're testing less than p naught. And we get the same answer. Okay? Do we see how this works? All right, well, great. Thank you guys for listening. If you have any questions, please feel free to type them in the chat. Please feel free to ask in the Zoom session. Thanks to Confused for the t-shirt. for both today and last time. I forgot to mention it last time and I feel terrible. All right, anyway, thanks for coming. See you guys later.